For problem 21, part A, we're using a right-hand Riemann sum to estimate the area under the curve using 12 subintervals. So we're going from -3 to 3, which has a distance of 6. But we're breaking that up into 12 subintervals. So we're doing 3 minus -3 divided by 12, or 6 over 12, which is 1/2. That means the base of each rectangle, that's our delta x there, the base of each rectangle is going to be 1/2. Right, we have 12 subintervals there. Each one has a base of 1/2. So the directions ask us to set up a sum in sigma notation, then use our calculator to calculate it. So what may help you to kind of set this up is look at the first 3 rectangles. Our first one, base is going to be 1/2, times the height, well, our right-hand Riemann sum, that means between -3 and -2.5, the right side is where we get our height from. So we have to put -2.5 into the equation to find the height. So our equation is x squared plus 1. We're going to put -2.5 in that equation. So -2.5 squared plus 1. So here we have the base times the height. That's our first rectangle. Then we're going to go ahead and add the next rectangle. That base is going to be 1/2 again. The height comes from the right side of the interval. So the right side is -2. So we have to put -2 into the function to find our height. So we have -2 squared plus 1. Base times height. Then the third one, we're going to have a base of 1 again. I'm sorry, base of 1/2. And the right-hand endpoint, so we're going to use -1.5. We're putting -1.5 into our equation to find the height. So this gives us the height of that rectangle. And we would keep going with this, but we don't want to keep writing these out. So what we're going to do is go ahead and simplify this and write it as a sum. So our sum is going from n equals 1. I know we started here at -3, but this n represents the subintervals. This is the first subinterval or first rectangle all the way up to the 12th rectangle. So these numbers have nothing to do with the numbers on the graph. We're going from the first one to the 12th one because we're going to have 12 rectangles all together. Then all we're doing is adding up the area of each rectangle. And you can see from these that they're pretty similar except for one thing. The only thing that's changing is this number. The base is always 1/2 times the height. That's the function that we're plugging in. But the number that we plug in to find that height changes. So we have to figure out what that is. So it's going to be something squared plus 1. Well, that something squared can be figured out by looking at these numbers. The numbers we're plugging in for x. First we're using -2.5, then -2, then -1.5, and so on. So you should see that there is a common difference. It's going up by 1/2. So a sub n is going to be 1/2 times n plus c. Remember our formula we talked about? A sub n equals the common difference times n plus c. C is the first term minus the common difference. Or in other words, this value minus 1/2, or you can think of it as what number would come before this in this sequence. So in this case, -2.5 minus 1/2 would be -3. And you'll notice that number happens to be this number over here, our a value on this interval. So that's always going to be our a value. This is going to be our common difference. So we're going to have 1/2 n minus 3. Now we have our sum set up. We can evaluate that sum using our calculator. So we're going to do second stat, go to math, fifth option there is sum, then second stat, go to ops, our fifth option is sequence. First thing we're going to put in is this function. So I'm going to put in 0.5 times, now the first set of parentheses is for the whole thing. Then I'm going to have parentheses around what's being squared there. So 0.5x minus 3 squared, oops, and then plus 1. And I'm going to close the parentheses right there. So we've got our expression in there, then comma our variable x, comma starting value is 1, comma ending value is 12, comma, and our step is 1. It's going up by 1 each time. 1, 2, 3, 4, all the way up to 12. Close our parentheses and hit enter. So our sum for this one comes out to be 24.25.